And we're live, yay! This is Math 60 Intermediate Algebra, and this is 9.4 and 9.5 chapters on logarithmic functions. So we're going to start off with a word that I have never told you about called logarithms. You may have heard them from other classes. Logarithm is the best buddy of the exponential, and it dates to the 1500s. So they've been around for quite a long time. So let's talk about them. We're going to start off with looking at this table. This is the exponential 2 to the x. And this is a table that we talked about in the last section. You know, if x is 0, then y is 2 to the 0 is 1. And if x is 1, then it's 2 to the 1, which is 2. And if x is 2, 4, 3, 8, and then a couple of negative numbers to look at the fractions. And this is pretty straightforward. This is the exponential function. So what we're going to do is we're going to take the x and the y, and we're going to swap them in this bottom table. So if you take a look, I've got 0, 1, 2, 3, -1, -2. These are now all the y values. And the y values to begin with, 1, 2, 4, 8, 1/2, 1/4, are now the x values over here. If we swap x and y, we end up with something we call a logarithm. I said that funny, a logarithm. And this is called a logarithmic function. Specifically, and I'll remind you, when I look at y equals 2 to the x, 2 is the base. So when we look at a logarithm, we say log base 2. So we still remember the idea that 2 was the base, and we still call it a base here. That's when we switch the question and the answer. So already you're probably like, whoa, why are we doing that all of a sudden? Well, we've been doing that for a while. We taught you about squaring and then square roots, cubing and then cube roots. So there are a lot of things that go in opposite directions, and this is just one more. If y equals 2 to the x, then x equals log base 2 of y. A logarithm is a function of the form y equals log base b of x. This is pronounced log base b of x. That's how you pronounce it. And the first question, because now we're getting into analysis, right? Math 60 towards the end, instead of just looking at the numbers, you're analyzing the graph. You're analyzing more about a function. And so my question for you, what is the domain of y equals log base b of x? And you're going to say, I have no idea. And I'm going to say, well, let's look at the range of an exponential. And if we assume that, right, b's got to be greater than 0, not equal to 1, I'll remind you that we had a couple graphs. One of the possible graphs looked like this. Remember that? And one graph looked like this. It depended on whether or not the base was a fraction. And it went through that point. And hopefully you guys remember that that was the 0.01. And this is y equals b to the x, depending on whether or not b is larger than 1 or smaller than 1. So for this, the range, so that's what could the y values be? The y values are all going to be up above. Remember, these are asymptotic. They never touch. So the range for this is y is strictly greater than 0. So that means with log base b of x, the domain has to be x is greater than 0. Why? What did you guys are looking at this going, what is even going on? Well, let's remember, I started out with this weirdness. I said, let's swap x and y. We flipped the x column into the y's and the y column into the x's. So we've swapped. And so how do we fully swap? The domain is what used to be the range. The x's are what used to be the y's. Okay, fun fact. Scottish mathematician John Napier, who lived from 1550 to 1617, but I think it was in the 1500s, coined the term logarithm from the Greek logos, meaning proportion or ratio. So it has to do with looking at ratios. It's hard. It's a little bit hard to look at it from that perspective, but let's look deeper into this. Let's see what the heck is going on with these things, because they are very cool and they are very useful. Another way, and they are also sideways. Sorry about that. Okay, sorry. Another way to think of logarithms is as a counting function. So if 2 cubed equals 8, then log, that shouldn't say that. That should say log base 2 of 8 equals 3. So it takes 3 2's multiplied together to make 8. So log base 2 of 8 asks the question, how many 2's multiplied together make 8? And the answer is 3. So let's approach logarithm this way. So log base 2 of 16. How many 2's multiplied together equals 16? And if we think, 2 to the 4th equals 16, then log base 2 of 16 equals 4. There are 4 2's multiplied together to make 16. Okay, how many 2's multiplied together make negative 16? And the answer is you can't. You can't multiply 2 times itself and get to anything that's negative. So this is either not possible is one answer. Undefined is another one. You're not allowed to take a logarithm of a negative number. It just doesn't happen. What's log base 2 of 0? Same thing. Not possible or undefined. Okay, next one. These are getting easy. Not possible, not possible, no, most of the rest of these are possible. How many 2's multiplied together make 1? So in other words, 2 to what power equals 1? Do you guys remember? It's a very particular one. 0. 2 to the 0th power equals 1. Okay. That one was a little bit hard. How about 64? How many 2's multiplied together give you 64? I think it's 6. 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. So let's see. 2, 4, 8, 16, 32, 64. Yes. So there are 6 2's multiplied together give you 64. So when I say, how many 2's multiplied together give you 64? You would tell me 6. How many 10's multiplied together give me 100? You're right, it's 2. 10 squared equals 100. So the 2 is the exponent becomes the answer. How many 10's multiplied together give me 1,000? 10 cubed is 1,000, so this is 3. Is it kind of starting to make sense? It's a little weird at first. If you've never, ever, ever heard of logarithms before, this is all like random. So I would say just keep practicing. And here I'm going to give you the rule written out. Exponential form goes to logarithmic form. They are intertwined. They are, I'm trying not to say a word that we haven't told you yet, but you're going to learn later in algebra. They are inverses. We have switched x and y. And so they are basically like evil twins of each other. So if a to the b equals c, so a to the bth power equals c, then log base a of c equals b. Log base a of c equals b. So we have to switch sides. And the arrow goes in both directions. You can either start at logarithms or you can start at the exponential. Okay, shall we practice? Now, this requires learning a pattern. If I have 3 squared equals 9, you start here, and then you move across, and then you move back. So you go log base 3, you start on the left, of 9 equals 2. How many 3's go together to make 9? 2 do. Okay, so then the next question is, well, if we were in logarithms, how would we get back to the exponential? Well, let's start. You start down on the left, 3, go across, 2 equals 9. So you always start down low, go across, and come back. Do a little circle. Okay. 4 to the x equals 16. Start here, go across, and come back. Log base 4, go across, of 16 equals x. What is x? X in this should be 2, right? How many 4's go into 16? How many 4's multiplied together go into 16? 2. But it doesn't ask us for that. It just says rewrite the following in logarithmic form. Okay, x cubed equals 9. Now this one's a little weird because a lot of people are like, oh, 3. 3 cubed equals 27. It doesn't equal 9. 3 times 3 equals 9. This number is actually a nasty little irrational number we don't have to worry about. That's like 2 point something. But again, how do we do it? We go from here, we go around in a circle. So we start down low, we go log base x of 9 equals 3. And again, what if we want to go back to this? You would start down low, x to the third equals 9. So wherever you're starting with, go around, start low on the left, and go around counterclockwise in a circle. I didn't put boxes around these. Let me put boxes around these. Okay, let's do one more set, and then we'll call it a video, and then we'll start the next video. We get to learn about particular types of logarithms. Rewrite in exponential form. Oop, that should be 2. Oh my goodness, someone had fat fingers today. To solve for x. So I've got log base 3 of some number equals 9. Now remember what I said. You start down low on the left, you go across the equal sign and come back. So this should be 3 to the 9th equals x. Well, if x is 3 to the 9th, I just have to calculate 3 to the 9th. 3 to the 9th equals, so 19683 is x. Okay, log base 2 of 8 equals, oops, what? Don't look at that. No, my hand is just not helpful today. What? Look, it's a pterodactyl. Log base 2 of 8 equals, we don't know what. I wonder what it could be. It certainly wouldn't be 3 just because I wrote that. Oh my gosh, my hand knows more math than I do. So we start down low, we go 2, we cross the equal sign, and we come back. So we go 2 to the x equals 8, and then we say to ourselves, 2 cubed equals 8, so that means x must be 3. Woohoo, woohoo, yay. Okay, next video, we will talk about 2 special logarithms, and we will talk about some more things you can do with logarithms. Woohoo.